Welcome back to your flipped classroom. I know, corny, but it sounded good. Guys, we're going to go ahead and talk about lesson 5-6 today, the fundamental theorem of algebra. And we're going to start off with a little bit of a review. Remember that when we've done this in the past, we have taken the zeros that we already know. We have said, okay, what does that mean? That means x equals -2, 2, and 4. The step right before that looks like this one, where each of the pieces are equal to 0. Now, once you get those and you put them all together to equal 0, now I'm not really explaining this because we've done this in 2 other chapters. We started it in chapter 4 and we've continued to do it in chapter 5. Remember, when you're multiplying, you take 2 things and you multiply them and get your quadratic factor right here, and then take that x squared equation, multiply it by the x equation, and get the cubic. Now, this is asking me for a polynomial function. When I hear the word function, I'm thinking, hey, that's that fancy notation, f of x. So I got my answer, my cubic equation right here, but I know I need to change it to function notation because that's what my directions asked for. Same thing with number 2. Now number 2, I wrote this one in factored form. Sometimes I will ask you to write it in standard form, and sometimes we'll write it in factored form. Now notice what happened. I have 2 factors of 2. This is what it would look like. And 1/2. Well, it would have to be x minus 1/2. Well, we don't like fractions as roots. So we'll multiply times 2 times 2. That way I clear the fraction and I've got something that's a little easier to work with. But again, this is called factored form. So I'm going to let you take a look at that for a minute and just remember the problems we've done just like that. Now, something that's new is we started talking about complex roots. Now, with those complex roots, we had conjugates. Now, conjugates, if you remember, they had the exact same real part, but that imaginary part, instead of plus, it was minus. So those 2 things kind of stick together. We could think of them as like buddies. Complex conjugates are buddies, where one is, the other one is right next to it. And we can do the same thing. There is a quadratic equation from those 2 complex roots. So let's take a look. If I went x minus whenever the number was positive and x minus 4 whenever the number was positive, isn't it safe to say that I technically did x minus a -2? And that's how this turned into positive? So we have a root. Roots are always in the form x minus r. X minus r is the factor, where r is the root. Okay? So that was in one of the previous sections that we did, but just to kind of bring that back and remember. So this is my r, this is my root, this is my other r. So what's happening is I'm going to go x minus r times x minus r. And I'm going to write my polynomial function. Now I'm going to go right to function notation and use f of x right there. The number that I'm going to plug in is the first root, 2 plus I. Now I have it in parentheses because I'm going to need to distribute this negative. So once I distribute the negative, and I will show it right here, let's put it in black. Once I distribute that negative, this is what I have. X minus 2 minus I and x minus 2 plus I. Now bear with me. Right now we're going to FOIL, well, sorry, not FOIL. Now bear with me. We're going to distribute and multiply this out. There's going to be a lot of terms, but just be careful, be patient, and we'll get through it just fine. So let's do the first term. Here, here, and here. So x times x is x squared. X times negative 2 is a negative 2x. X times I is a positive. Xi or Ix, it doesn't matter. I put them in alphabetical order. The next term that I'm going to be using is this green color. And the green color is going to allow me to multiply the middle number with each of the three listed here. So a negative 2 times x is a negative 2x. A negative times a negative is a positive 4. And a negative 2 times an I is a negative 2i. Those are the numbers that came from the second term. And finally, the last term. I'm going to put the arrows underneath. You notice I'm just being real patient and real careful with my answer. A negative times a positive is a negative Ix. A negative times a negative is a positive 2i. And a negative times a positive is a negative I squared. Now think about it. I squared, we know that from a previous lesson. I squared is secret code for negative 1. Okay, so instead of I squared, I think what I'm going to do is put negative I squared. And the I squared that it is secret code for, that number, is a negative 1. So do you see that this term technically went to a positive 1 and not an I squared at all? So let's simplify, put all this together, and we'll have our quadratic function. All right, final answer. F of x equals. And I think I'll put this in red so that we can identify the answer a little bit better. So f of x, let me switch that over to red. Is there any other x squareds that I can put with this? No. So there's the first term. This one's used. I'm actually going to put a little slash through it so I know it's been used. A negative 2x and a negative 2x, and there are no other numbers with x's. That's a total of minus 4x. I have now used those terms as well. I have a plus ix, and I have a minus ix. Those completely cancel each other out. They're gone. I have a negative 2i and a positive 2i. Those are going to cancel each other out. So the only numbers I'm left with, I have a plus 4 right here, and remember I had the plus 1 at the very end. Well, a 4 plus 1 just gives me my positive 5. So there are no factors of 5 that add to 4 except in the imaginary world, right? Because that's where these roots came from. They're imaginary roots. They're complex roots. But this is my polynomial. So this brings me to the fundamental theorem of algebra. On the fundamental theorem of algebra, in the box up here. Now, we've actually already done this. This looks like it's a new lesson. It's not. The fundamental theorem of algebra says the degree of your polynomial is going to be the exact same thing as your roots. So write in here, degree equal number of roots. And like I said, we already figured that out in an earlier section when we were graphing. So here we are. To find the real roots, we're going to follow these steps. Number 1, you can use a graphing calculator to identify the possible real roots. You can test the possible roots to find one that is actually a root. use synthetic division when you're doing this. Factor and find the remaining roots. Remember, if it doesn't factor, use the quadratic formula. Now, in this example, we're going to do this without a calculator, a graphing calculator that is. We're going to do sum with, we're going to do sum without. The ones that we'll do with the graphing calculator, I will help you with in class. So we're going to go back to old school, and where it says use a graphing calculator to identify the real roots, that's where we're going to do our rational zeros test. Okay, so on here, the very first thing is x the very first thing that we're going to do is find the possible zeros. Possible zeros, if you remember, all the possible roots are found by using those p's and q's. Now the p is that negative 20, and the q is the positive 1 that's in front of the x to the fourth equation. So all the factors of 20, plus and minus 1, plus and minus 20, plus and minus 2, plus and minus 10, plus and minus 4, plus and minus 5. So those are my factors of the top part. On the bottom part with the q's, I have plus and minus 1. So the possible roots of this equation are 1 over 1, 2 over 1, 4 over 1, 5 over 1, 10 over 1, 20 over 1, and of course it's plus or minus. So everything that you see up here are my possible those are the possible numbers that I need to try. How do I check them? Synthetic division. Okay, so let's pick. I always start with the number 1, so I'm going to start with the number 1 first. I'm going to do synthetic division because it's way faster than doing long division. I put the 1 in here, and now I'm going to use my coefficients. 1, 4, negative 1, 16, and negative 20, and they go right here. 1, 4, negative 1, 16, negative 20. And do synthetic division. 1 times 1 is 1. Signs are the same. Next step, 5. Answer's 4. Next step, 4. Those two things added together give me 20. Last step, 20. And awesome. Do you see how I get a 0 root here? If the remainder is 0, then we know that, yes, I just picked correctly. 1 is one of my zeros. So in my list up here, I'm going to tell myself 1 is a 0. Now, the good thing about this is that I started with an x to the fourth equation. That means if I started with x to the fourth, my answer is x to the third plus 5x squared plus 4x plus 20. So here's what's happening. How many zeros am I looking for? The degree is 4. If the degree is 4, I am looking for 4 zeros. Of the 4, I've got 1. The degree down here is 3. That means I have 3 more zeros locked up inside of this cubic function. Now there's a variety of ways that you can get your answer. If this factors by grouping, which I believe this one just might, if it factors by grouping, then by all means take that shortcut and do that. So let's rewrite this formula, and let's go ahead and let's factor by grouping. So I've cleared the screen where we were working, and I have put the cubic equation that we had. It looks like I might be able to factor by grouping. So I'm going to use this opportunity to reteach the factor by grouping method. And if you remember, these first two terms, we'll group them together, and they both have an x squared inside of them. If I take an x squared out of both of those, I am left with x plus 5. Plus, if I take a grouping of these two numbers, there is a number 4 that will divide out of both of those. And I'm left with x plus 5. Now, do you see that these two things are exactly the same? That's how I know that factor by grouping will work. So what you're going to do is you're going to pull those out. So it's just like taking those and pulling them out. So I am going to pull those out right here. And then what I'm left with is the part that's left over after I pull them out. So that would be x squared plus 4 equals 0. Now here's the good news. This is a linear term. I know that I can take x plus 5, set it equal to 0, move the x to the other side, and get an answer of x equals negative 5. Well, yay! Of the 4 zeros that I need, I now have 2. I have positive 1 and negative 5. There are 2 more zeros to go. Do you see this part right here? This is not the difference of 2 squares. You have to have a minus sign in there to factor that using the difference of 2 squares. This one is an imaginary answer. So let me take this a second, and let me take this part and focus it over here. Let's factor an imaginary situation. You would split your x's up. Now, here's the thing. There does exist a root, and we have a plus and a minus 2i that will work here. Now, some of you might be saying, how in the world, Mrs. Martin, did you just do that? Well, number one, I know that this is imaginary because there's no such thing as the sum of 2 squares. So this will happen all the time when you have the sum of 2 squares. But look at this for just a second, and let me take a look at it in light of a different way. I can find the zeros. If I take x squared equal to negative 4, and then I take the square root of a negative number, we know that that's a negative 1 times 4. In other words, it's an I times the square root of 4 that works out to plus or minus 2i. Now technically, I guess I probably should focus this plus or minus up in here because I really don't want you to forget about it. So if we just put that in, we'll carry it all the way through. That is a plus and minus 2i. So x minus positive 2i and x minus a negative 2i. Do you see? This is really technical, you guys. I'm really sorry. But what I'm doing is I'm following the x minus the root formula, that same x minus r that we had at the top of this page. It just, this is coming from x minus 2i and x minus a negative 2i. So I'm just trying to get you to think about where this came from. So this is really, you know how I always do those little think bubbles? This is a think bubble of how this came to be. All right, so how do I get answers? I actually already gave you the answers, but in this capacity, I would take x minus 2i, set it equal to 0. So x is a positive 2i. X plus 2i, set it equal to 0. And x equals a negative 2i. The last two missing zeros that were locked up inside of that x squared equation are a positive 2i and a negative 2i. Do I have 4 roots? Yes, I do. 1, 2, 3, 4, and I'm done. Okay, guys. Let's skip down to where it says conjugate root theorem. Because as I said before, conjugates occur in pairs. For example, if I gave you 2 plus 3i, you would know that the conjugate that goes with it is 2 minus 3i. Or we can do this with complex numbers that have radicals in them. If I gave you 1 plus I square root of 5, we'll put imaginary with the radical, so that's complex. Then the buddy that would go with it would be 1 minus I square root of 5. Those are called conjugates. And they always come in pairs. They're always buddies. So look at number 7. It says find all the zeros of the polynomial function. So we are going to start with the first assumption. I am going to use my graphing calculator. So this is the second method. And I'm going to say from graphing calculator. I will get a picture up on my screen, and I will see that this graph is crossing at the numbers -3 and +3. How did I know that? I looked at the picture, I looked at the graph, and I did calculate feature and found my zeros. So from the graphing calculator, I know that. In other words, when I take those numbers and plug them into this equation with synthetic division, I will get 0 as a remainder. And that's a good thing, because right now, how many zeros are locked up inside of here? 4. There are 4 zeros locked up inside of here. So I'm going to make my list off to the side. I know that I need 4. And by the way, 2 down, 2 to go, right? Well, let's go ahead and let's figure out what is left. If I take the number 3, and I'm going to synthetically divide that out. Watch your leading coefficients, 1, 1, -7, -9, and -18. That's 3, 12, 3 times 5, 15, 15 minus 9, 6, 3 times 6, 18, remainder 0. I'm not surprised. We should get a remainder of 0 since 3 is a 0. And then I'm going to do the same thing. Now, think about this. This was an x to the 4th equation. I divided out one of the x's, and now I am left with an x to the 3rd equation, aren't I? Now, of that x to the 3rd equation, I am going to go ahead and I am going to divide out my -3. So I'm going to copy these numbers so that it doesn't get too confusing. Only this time, I'm starting with x to the 3rd. So my answer will be what? What degree down here? You're probably guessing 2, and you're right. The degree down here will be 2 when I'm done. So let's synthetically divide and see what we get. 1, -3, 1, -3, 2, -6, remainder 0. So what does that mean? Once again, we started with a cubic. We are now down to an x squared. So the equation that I'm left with is x squared plus 1x plus 2. I am going to take that and I'm going to move it over, and let's work with it a little further. There are 2 more zeros locked up inside of there. So let's take that and go see what we can do. Okay, so I've cleared the screen. You can continue on yours. I still need 2 more zeros. This is the x squared equation I was left with. The very first thing that I'm going to try to do is I'm going to try to factor. I need the factors of 2 that add to 1, and there's no help of any number here. It is impossible to have the factors of 2 that add to 1. So right away I'm like, I'm not going to be able to factor. So I'm going to scrap that idea, and if I can't factor, I'm going to use the quadratic formula. So this is plan B, quad formula. Plan A is to factor. Okay, so the quad formula, x equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. Now let me fix that a second, because you know how much I like my skeletons. So I'm going to make sure that I put this in skeleton. I'm going to make sure I put this in skeleton format. Fill your numbers in. By the way, what is A? What is B? And what is C? You probably said 1, 1, and 2, and you'd be right. So I'm going to plug those in. B is 1, 1, A is 1, C is 2, A is 1. Now, of course, look that formula up if you need to. And simplify. When I simplify this, I'm going to have negative 1 plus or minus the square root. Now let's look here. I've got a 1 squared minus 8. So I have a 1 minus 8 all over the number 2. That is going to simplify to a negative 1 plus or minus the square root of a negative 7. Now I'm going to use this opportunity to use a think bubble. Because if I have a negative 7, that is the same thing as an I square root of 7. So since I know that this is a negative 7, which is an I square root of 7, I am going to put that in my problem and continue on. At this point, you may leave your answer like this. There are 2 answers. There is a negative 1 plus I radical 7 all over 2, and a negative 1 minus I square root of 7 all over 2. So let me just take this and transfer it up to the top so that we can have our final answer all together. Negative 1 plus or minus I square root of 7 all over 2. And those, my friends, are your zeros. How many did I need? I needed 4. How many do I have? 1, 2, 3, and 4. So I am done. And by the way, those of you, these are not the zeros of number 8. These are the zeros of number 7. That's about all we're going to do right now. I'm going to help you in class. You guys, this is really overwhelming. It's a lot of steps to put together at one time. Be patient. Pick up what you can, okay? And then we'll work on the rest in class. So have a good night. Bye-bye.